Okie dokie. So I think she just wants the basic draw the right triangle A, B, and C, and we'll draw an angle here, and we'll say that we're trying to prove that sine squared theta plus cosine squared theta equals 1. So I'm going to start with the right side, sine squared theta plus cosine squared theta. Sine squared is the opposite over the hypotenuse, and cosine is the adjacent over the hypotenuse. And so we have b squared over c squared plus a squared over c squared, and that's equal to a squared plus b squared over c squared. And note, because it's a right triangle and it satisfies the Pythagorean theorem, then a squared plus b squared equals c squared, and c squared over c squared is 1. So indeed, sine squared plus cosine squared equals 1. Check. And then for number 3, now we can use that sine squared plus cosine squared is supposed to equal 1. So 0.839 squared plus cosine squared equals 1. So cosine squared will be whatever 1 minus 0.839 squared is. And my calculator is telling me that's 2.296079. And I'm going to take the square root of that. And so the cosine of theta is going to be either plus or minus 0.54413. And that's why she's telling you what quadrant it is, to figure out if it's plus or minus. So if you're in between pi halves and pi, you're in the second quadrant. Cosine, the x value in the second quadrant is negative. So we're going to say negative 0.54413. Check. We'll do the same thing for number 4. If you take your sine squared theta plus cosine squared theta equals 1 and divide the whole thing by cosine squared, you'll get the other identity. Cosine squared theta. So sine squared divided by cosine squared is tangent squared. Cosine squared divided by cosine squared is 1, and 1 divided by cosine squared is better known as, you know what? Okay, I was going to do it this way, and I was going to use tangent to find secant, but it's not actually my favorite way of doing this one. So instead, and we could have done the one that we just did like it too, but it was so nice that I just did it straight from the identity. So this one, I usually just, triangles are your friend, so just draw your own triangle and make the tangent be the opposite over the adjacent, and then grab the third side with Pythagorean theorem that 1 squared plus 1.376 squared needs to be c squared. So if I take the square root of 1 squared plus 1.376 squared, I get that c is 1.7. So that's 1.7. And then I lucked out that I was in the first quadrant, so my triangle is in the first quadrant, everything's positive. And then I can get sine and cosine no problem. So the sine of the angle is the opposite 1.376 over the hypotenuse 1.7. So 1.376 divided by 1.7 is 0.809. And then the cosine of the angle is 1 over 1.7 is 0.588. And that is all they wanted. They're both positive because we're in the first quadrant and everything's positive in the first quadrant, so we don't need to worry about that. Cool. Let's see, so then we'd have these simplifying ones. These are fun. You're just using your identities to change everything into cosine and sine is helpful. So tangent squared is sine squared over cosine squared. So the cosines will cancel out. and you'll just have cosine squared plus sine squared, and that's your Pythagorean identity, so that's 1. We do it again. We'll rewrite tangent to sine over cosine. We multiply that by sine. Oops, these are x's, all x's. And so at the top we've got sine squared x. When we multiply sine times sine, we get sine squared. The bottom is cosine x. If I want a common denominator, I'm going to multiply this guy here by a fancy form of 1, cosine of x over cosine of x. So now this guy is going to be cosine squared x over cosine x. Now that they have the same denominator, I can add the numerators, sine squared x plus cosine squared x over cosine. And sine squared plus cosine squared should be ringing bells. That's 1. So 1 over cosine x, and that's better known as secant x. So when they say simplify, they usually simplify to one nice term, like so. Let's see what else they got. We do it again. So sine, we'll make the tangent sine over cosine. So it's the same deal. God, is this the same problem? Tangent, sine. Yeah, it's the same problem. They just wrote it in a different order. Sine, tangent. Yeah. So that's the same as that. And then this one, cosine squared plus sine squared is 1, and 1 plus 1 is 2. Ha ha. All right. That was fun.